My name is Jay Schmidt, and I'm going to be presenting this webinar for you today, covering heart rate variability. Just so everyone's aware, the first 30 minutes of this webinar are going to be used for just demonstration of the software, and then the final 30 minutes we're going to reserve that for Q&A. Please feel free to ask any questions as soon as you think of them. We have a few people in the background that are going to answer this for you. And then if there's anything a little bit more complicated or complex that would be good for the group, then they'll shoot those questions to me, and then I'll show you a visual of how to answer those. Okay, so just to go over what we're going to be covering here, as you can see, we're just going to be going over basic analysis configuration, just general RPeak editing practices, some common pitfalls, some guidelines that we go over, how to load these data after you've edited them if you needed to view them again, and then finally how to export these into Excel so that you can then export them to your statistical package program. Okay, so let's go ahead and get started. So I'm just going to go ahead and open HRV here. And I'm going to load my file. First thing you're obviously going to want to do is make sure that you map your channels. These are already mapped for me. I've opened this file before. But if not, then obviously you're just going to want to align your ECG with your ECG, ZZT, Z0, and so forth. So we're all set here. I'm going to hit OK. Just to go over some main things of the program, and then we're going to go into analyses. So just to show you some settings first. Okay, so first at the top here, we'll see that we have my file path loaded and the length of the file. During this webinar, we're only going to go into time mode. There's a few different modes here, as you can see, events in time, and real time that you can use. But just because we only have a certain amount of time, we're just going to show time mode for now. Below that, we're going to see in our events and modes, if there were any events within this file, they would be listed here. And I'll bring up a file in a little bit after this one, and then those will kind of display those events for you. To the right of that, we're going to have just some basic settings on our segment times that we want to look at. This one is currently, the default is 60 seconds. If you did need to change that, you can just come in here and change to something like 30. Or you can use this cursor bar over here to change the time. But we're going to go ahead and leave it at 60 just because that's standard that we're used to looking at. And then also, if you knew there was a time that you wanted to start it besides the actual beginning, you could just place that here, and then you would start from that part forward. Next tab over is going to be your calibration settings. Most of these you're probably not really going to have to change that often. If anything, you might be changing your bands here that you're looking for, your frequency bands. These will be something you want to change if your population is children or elderly or something that their heart rate availability would be different. So you can change those right here. And if you guys had any questions or concerns on you didn't know what band to use for your particular population, we do have a website with a support article that will actually speak to our recommendations or some recommendations for these. And you can get that at support.mindwaretech.com. Okay, and so yeah, these are pretty much going to be standard set alone. But again, if you did feel like you need to change it, go ahead and check out that article, or you can send us an email. Next thing over to RPeak artifact settings. This is pretty similar in that you won't usually have to change anything. One thing might be your maximum heart rate and your minimum heart rate if you were studying a population that was above or below 240 or 240 beats per minute. Your peak sensitivity, this is something that you, again, probably won't have to choose or mess with. I will show you these settings when we actually go into analyses, as this is also available there. But the peak algorithm is pretty good at detecting all the R peaks, so this isn't something you'll normally have to do. Over on the filter side, if you ever observed anybody that had a really noisy file, like in between all of your R peaks, you saw a bunch of noise. It could be that the subject was touching a cable that was plugged into the wall, or their cell phone that was charging currently. So what you could do to alleviate that and still use these data would be to turn on this notch filter, and then that'll really help clean up some of that noise. So if anybody felt like they might have a need for that, or they had a messy file in which you thought you had 60 hertz, You could try that, or you could also, just send us a screenshot or something and confirm this is what you should be using. Okay, so next tab over, additional settings. This is going to be mostly just your video and editing stuff, but um, if you are saving your video files in a different location than the correlated physio files, then you can go and find these by just clicking on this folder and then loading that video file. But if you were doing your experiments in a manner in which you're saving your video and all your physio in one spot, then the HRV program should automatically load all those videos for that associated MWI file. Once you do load these, you want to make sure that to view the videos that you just click this little icon here, and that'll actually ensure that the video pops up when you go into analyze mode. And then one other thing, we're gonna come back to this, but this is the edit settings. This is how you can actually load an edited data file if you're looking to look at someone else's edits that they've done before, or reopen the edited data in HRV. Okay, so we're going to go into a little bit more detail on everything once we hit analyze, so let's just go into that now, and then we can circle back if need be. Okay, so once we hit analyze, first screen that pops up is going to be our invert check screen. This is just asking, is your ECG inverted? So it's pretty somewhat common for some people to accidentally flip the polarity. They put the positive on the top and negative on the bottom for their ECG, and so what that'll do is that'll actually invert the cardiogram as you would expect. So this is a way in which if you did accidentally do that, you could still preserve all your data and still be usable. Ways to go about kind of looking at this are just looking for landmarks. So you can see that your R peaks should be the highest peak amplitude in most of this, and so you can kind of clearly see here that this is not inverted. But if you did have it where the peaks were going way down, much more than they're going up, then that you could have inverted it. So we're going to hit no here because it looks clean to me, but that's how you could alleviate that. Okay, so now we're going to actually go over, kind of give you a brief overview of everything, what you're looking at. So these are basically, this is your ECG window. This is basically showing your QRS complexes and your R peaks right here, with the blue dots symbolizing just good R peaks and timing. Below that, we have our IBI series, which is derived from this R peak timing. And then we basically filter and interpolate the IBI series to produce this time period series right here. And then we perform basically a fast Fourier transform, and then which we calculate the RSA. And then here is my respiration, which I'm pulling in from my DZT Z0. So those are basically the different graphs that you're looking at here. Over to the right, we're going to see all of our stats for this particular segment. So heart, respiration rate, all of that. So if we wanted to look at respiration peak frequency, it says here 0.2335. Coming over to here, we can see that that's probably about accurate because it looks like it's the peak frequency here down in my respiration power spectrum. So just kind of showing you how things line up here. And then you'll also see that you have your mean heart rate, mean IBI, and your number of R peaks right there. And so all of these data are exported along with your physio to the Excel file, which we'll view in a little bit. But this is sort of just explaining where it all comes from. And then obviously we have our very low, low, and high frequency, which is basically represented here between these two bars. So very low, low, and then your high frequency. Okay. So now we're actually going to go into editing these data to see exactly what we would do in certain circumstances. Right off the bat, these look pretty good to me. Nothing's being flagged, so I really wouldn't be concerned with these, and I would probably move on to the next segment. So we're going to try to look for something that's a little messy. Okay, so here's a good instance of something that we would want to look at. We can see that there's the algorithms, the software is detecting that there's an error or something that we just need to look at by these little yellow stars. So what we're going to do is we're going to zoom in on that area to see what's going on. At the bottom left here, you'll see that I have my windows. This one right here is kind of my favorite, the second one for zooming in as far as HRV, zooming in to see what the issue is. So we just click on that and then click and drag to the area that you want to look for, give you a closer view. Okay, so this looks like maybe there was some motion artifact or something. It's hard to say exactly what it is. But what we do in this instance, there's a few different things we can do. So I'll show you those methods. To begin with, what I would start with here, it looks like there's maybe some sort of double peak going on here. So what I would do is I would kind of back up a little bit. And if we touch this this far left icon here, we can actually now grab these vertical bars here. And these are our X cursors. And so basically what we can do is we can drag one over a known good R peak and then drag the other one over another known good R peak, just kind of get our timing, just a general. And then we can kind of line that up to see that they line up. And then we can see, you know, which one's maybe a little bit more likely to be the actual QRS complex. And in this instance, it looks like this one almost lines up perfectly with that. So I might zoom in again to see a little bit more, but I would probably end up deleting this first one, and then this window right here will let you back out to everything. And then it looks like that what that did was it set my other R peaks to my blue instead of the yellow flag, saying that the timing is, you know, within range of what you would expect. And as far as the amplitude of these, you know, that's not really something we're concerned with in HRV. We're more concerned with the timing between the R peaks. So it would be perfectly fine to leave them like that too. But let's go ahead and zoom in on this second guy just to see what's up with him. Okay, so it looks like, once again, there's some sort of movement here, something like that. Maybe electrode was tugged and it made a little dip here. So what it's saying is, you know, there's the timings off between all of those. So what I might do in this instance is come here, and then, so at this point, we're not exactly sure, you know, this could be the QRS, this could be the R peak right here, but we're not exactly sure because of all this movement. So one thing we can do, and this is a good instance, is we could do a midbeat here. So what we're going to do is we're going to grab our X cursor bars and we're going to place the right one to the right side of that known good R peak, and then this left one to the left side of that. And then we're simply going to hit this midbeat button up here, and it's going to put it at where it thinks it should be. This one is a little tricky because of that, but this would be okay to leave here as there's not a lot of these instances, but you could also try putting this in here. So it likes this timing a little bit more than what the midbeat picked. So you could also leave that there. I would probably go with this guy for this segment. So now we see that there's a little bit more actually at the end here. So let's zoom back in there. Okay, so now we're seeing kind of the same thing going on here again. So it looks like basically I would probably grab these bars again. Let me back out. Okay. Give myself a little bit more room. Okay, perfect. And I'm gonna get my timing again. Just try to figure out some of these. Okay, and I'm coming over here, and then we can basically see here that this one again is lined up, so then I can simply come over here and delete this. And just to show you guys this delete function up here that I'm using, once you click this, you're going to be presented with this little circle, this yellow circle. By moving my mouse wheel, I can actually change the sensitivity on this. So if there were a bunch of points in here, and I'll demonstrate that now. If there are a bunch of points in here and you wanted to be more precise, you could kind of, you know, just snipe like individual ones without having to get all of them. And you can also change that sensitivity with this bar right here. But okay, so I've deleted that first one. That didn't look like an R peak. And then I'm going to go ahead and delete these two also. And so go there. And then that right there will basically preserve all those. And then it looks like those all lined up. So that's probably what I would do in that instance. Okay, let's look at some more segments to see what we would do with those. It's kind of the same thing. Okay, this one's pretty good. Okay, So now I'm going to demonstrate an instance in which you would want to use one of these delete all points between X cursor or Y cursor. So in here we can see that I have a bunch of points in here. This kind of looks noisy in here, and the software is detecting a bunch of different R peaks for whatever reason. So what we're going to do is, because we know our other peaks are way up here, is we can delete all of these points in here without having to go in here and actually have to physically delete all of these. We can just simply move our Y cursor above all of this noise and then this lower one below it, and then click the delete all points, and that'll remove all of them, 4 of those. Now in doing that, what I see is we have deleted what should be probably an R peak between these 2 yellow stars. So now we'll have to investigate that a little further. So I'm going to zoom in again. And this looks like it's probably where it should be, but just to be sure, let's go ahead and try our midbeat again. So I'm going to move this to the right of this guy, this over here, and I'm going to leave my snap to peak. So the snap to peak is basically going to snap it to the highest point within there. And so you'll want to normally leave these on, but we'll see how this deals with this. So I'm going to hit midbeat. Okay, so what this has done is it's actually saying that this is where it feels like the our peak should be, and that's probably not correct because it's so close to this guy. So in this instance, I would probably turn this auto peak off up here, and let's go ahead and delete this guy. And when you turn that off, what it's going to do is it's going to place it as far as the exact middle between these 2 R peaks. So the amplitude is not correct, as you can see, but it did place it where in the middle where it should be. Now, this is good because now I can kind of validate where the R peak actually should be, because you can see where it's placing it. It's almost directly below where I thought it would be initially. So then all I have to do is come in here, put it where it should be, and let's back out. And then all of everything else is lighted to the blue circles again, so we're good. So that's a pretty good example of what you could do. Use the midbeat for if it doesn't detect it at the right peak, or if there's a bunch of peaks in between and it's not sure which to choose. That's a good way to alleviate that. Okay, let's move forward here. Okay, this looks, let's zoom in here. Okay, so this is a pretty good example of something that is being flagged because of tie-in purposes, but you wouldn't necessarily want to do anything about it. Because you can clearly see the QRS complex, we can see the TE wave afterwards, and it just looks like an actual 2 actual beats here. So in this instance, you wouldn't want to do anything, and you would want to move forward. The name of the game is not to get rid of all of the yellow stars. It's to ensure that everything is correct. So in this instance, you would just leave these yellow stars as yellow stars and move forward. And let's see here. Let's look at this noise here. Okay, so this is another instance in which the delete everything between the Y cursors would be best. So let's go ahead and give that a shot. Okay, so yeah, immediately after doing that, it stopped the algorithm from detecting this noise as our peaks, and it kind of fixed all those. So that's another easy instance. So it's a pretty powerful feature that you could find handy. Let's look at this a little bit more. Okay, so in this one, again, it looks a little noisy. I'm going to grab my cursors here, line up my timing, and then move forward. Okay, so from this point, it looks like this was an actual good R peak. And then it looks like after that, there is quite a bit of noise here. So what probably is the case is this is the R peak. And so what we'd want to do is delete these just because of the timing. And then yeah, that pretty much lined all that up. So that's a really another good way to, if you have something like this where it's really hard to tell even when you zoom in, then that's why this these X cursors lining up over some IBIs right before, and then kind of seeing where it should be is really helpful. So that's another instance which has helped out. Okay, so now let's go into kind of showing writing this out to Excel and showing how to load these edited data files again. And one more thing before we move forward, I just want to talk about the 10% rule. Basically, this is sort of just an industry standard on how much of these data you want to be editing before you consider throwing out that segment just because it's not valid. Let's just say there was too much noise or something. So from segment to segment, you just want to make sure that you're not really editing more than 10% of the total data. And if you ever came in an instance in which you had just way too much noise, I'm going to see if I can find something real quick, during the beginning of the file. And what our first recommendation would be to, use the practices I just showed you, go through here and see if you can clean these up. If it's just not possible, one thing you can do is you can basically delete this section of the data. Now, you want to be careful with this because you can't have a beat in the beginning and then one in the end, because the software will just kind of consider that as one really long beat and it'll throw off all your stats. But what you can do is you can move your X cursors to the left and the right, just like the Ys I did, and you can delete everything between there. Now, one caveat to this is that to calculate a valid RSA, you need to have at least 30 seconds of continuous data within that segment. And so if this were to occur somewhere around the middle, then you basically wouldn't be able to use this segment if you were considering deleting that portion out, because you're going to have some here and then you're going to have a bunch on the right side. So even to delete the first 31 seconds wouldn't be valid, because then we would only be left with 29. So this would be okay to do. This wouldn't be the best circumstances. I can see some R peaks here, and I would like to clean it up a little bit more. But if you did have something extremely messy and you couldn't, then that's something you could do, and they would still give you some valid statistics for that segment. Okay. So now let's go into writing these out to Excel, and then we will go into loading this back up again so that we can see these edits. So let's go back to this first segment, and we're going to start to write these. I didn't do any editing here, but once you are done with all your editing, we usually recommend that you come back to your first segment and then start writing them out. So all you need to do that is hit this write button. It's going to ask me if I would like to create a new Excel or select existing. I'm going to go ahead and say create new. And then what it's going to do is automatically open up Excel, and it's going to fill in all of these data into the appropriate columns. And so as you can see here, it's just your basic information about the file, the length, the sampling frequency, stuff like that. And then down here is probably a portion that a lot of importance is put on. This is where you're going to find your RSA, mean IBI, number of R peaks, all of that information. And then finally, you also have some tabs at the bottom where you can actually see the timing for your IBI series, your power band statistics, the timing series for heart periods, and stuff like that. So that's how that is done. Pretty simple. Once I'm done doing that, you're going to want to save your edits. To do that, you want to make sure that you hit the Done button. It's going to ask me where I want to save this edited data file, or this EDH. You'll normally want to place this in the same folder as you had your physio in there. So it's already doing that for me automatically, and so I can simply hit OK. To open this back up, and I'm just going to close out just to start from the beginning. And if I show you the folder here, this is the edited data file. As soon as I edit something, it's going to give me a user preferences for my settings. And then my edited data file that we just saved is right here. So this is the edited data H for heart rate variability. So this is the actual file that we would be loading here in a second. So let's go ahead and load HRV again. Okay, and I'm going to want to load, if you have an MW file, most people probably have an MWI at this point, but if you have an MW file or the MWI, this is what you're still going to load at this point. You do not want to load the edited data file. Our channels are mapped. You load the edited data file under additional settings, edit settings, and then if you wanted to use some edited data, you simply click this. It's going to open up, say, where is your edited data file? Here it is, again, my EDH. And then now when I go to analyze, it's going to be pulling the MWI file, but it's going to be loading all of my edits also. So let's go back in to confirm that. So we can see here there was some noise that we cleaned up in the third segment, and we can see that all those edits that I did before are loaded. So that worked appropriately. So that's how you can actually load those if you needed to afterwards. Okay. So that is basically all of the portion that we have for the tutorial on just the general guidelines. So now we're going to open it up to Q&A. And so if you want to go ahead and send your questions through, and then they will be sent to me, and then I can show everyone basically on screen if there's anything for the group. So I'm going to go ahead and put myself on mute, and then as soon as I get some questions in, I'll come back on, and then I'll answer them for you guys. Okay, we have one question about how do you know what percentage you've edited? There's a few ways you can go about this. One easy way is basically in how many you're artificially creating. So let's go to the third one. So this one right here that we had to, actually I think it's 6. Yeah. This one right here that we had to kind of put there artificially, that would be 1. But basically how you can do that is you have over here on the right side, you have your HRV stats with the number of R peaks. You have 79. So I would certainly consider that as one of those 79. So then you can just obviously divide the 78 by 79 to get your percentage. Okay, we have a question here about showing how to delete within a segment and not just the beginning. So we can go ahead and show that. Okay, so let's just use this segment as an example. Let's say you had something in the middle of it, you still cannot come in here, and let's just say the noise is right here. You still cannot use this. You cannot do this because it's basically going to skew all your stats as it's thinking that the beat right here from about 323 to 330 seconds is one long beat, and I can show you that here in a second. So let's just look at the IBI 75, and then if I delete some from the beginning, so that went up all the way to 855. So that's obviously not what you want your interbeat interval, your mean to be. So the only way you could really get around this is, hopefully it's before you still have 30 seconds of continuous data. So let's just put these back in here. Okay, so what you could do is if the noise basically occurred at any point before that 30-second mark, so which is right here, then what you would have to do is you would have to come in here and delete everything either before or after that. That's how you would kind of get around that, just like that. Okay, we got another question here about showing the RSA value per segment, or if it's in the spreadsheet. So again, we can just go ahead and write this out, create a new one. And this is my RSA value for that exact segment. And this is actually a pretty good time to show you guys how this will work if you're deciding to not write every segment, let's say. So right here, we'll see our segment number, and this is number 6. If we come back in here and let's say that we decided now we're going to write number 5, you can come back and write that, and what it'll do is it'll hold that spot for it, and then it'll retrofill back to where it should be. But here's my RSA for segment 5, and then for segment 6. Okay, next question is a little bit of a clarification on the 10% rule. So the question was, is there editing a peak that is a yellow star considered part of the 10%, or are you referring to deleting chunks? So the 10% rule is basically referring to R peaks when you cannot see them. If you can clearly see the QRS complex, then that really wouldn't be considered part of that 10% rule. So let's go back to segment 6. And we'll zoom in a little bit here. So this certainly looks somewhat like a QRS complex, but you can't say exactly for sure. Looking at the other data around it, this certainly looks like one. But this is probably one of those in instance where I would say that I would probably count it as part of the 10% rule. But if you can see it clearly, like if you can see, let's go to a different segment here. If you can see it just like these, I mean, those are picture perfect QRS complexes. I mean, or P wave or T wave after that. Then if let's say that the algorithm accidentally put one here and not here, deleting this and putting this in would not be considered part of the 10% rule. It would only be if you had to artificially put it in there, or you're having to estimate where the R peak would be. And then as far as deleting the chunks, all you really need is that minimum of that 30 seconds of continuous data. So that wouldn't really be, the 10% rule would not apply to that. All right, we've caught up with all the questions that we've been asked so far, so if you guys have anything, please send them in. Okay, we have a question here about what if the amplitude of the R peak is lower than the rest? So lower amplitude can be caused by movement artifact or by the recording technique. But as long as it's clearly identifiable as an R peak, then it's valid. Just because, again, with HRV, we're concerned with the timing of the R peaks, not the amplitude of them so much. Next question we have here, can I load impedance edits into HRV? So our other application, which is impedance, they want to know if basically you can load those edits into HRV. So yes, you can, as long as the editing techniques for impedance are valid HRV edits. So for example, if you have a contiguous R peak series in HRV but not in impedance, then that would work. And there's also another support article on our support.mindwaretech.com. So if you needed any further clarification on that, you can view it from there. We have another question here about how small can I make my segments in HRV? So 30 seconds is the shortest you could make them, just because to calculate that RSA, you're going to need a minimum of 30 seconds. And then again, if you did decide to do anything within there and you had a section which you had to delete, then you automatically wouldn't be able to use that segment because there would be some time in which you would have to delete it. So that wouldn't be valid for RSA. Again, if anybody has any additional questions, please go ahead and send them in now. If anybody was planning on leaving at this time, we just want to thank you for attending the webinar. And I just wanted to remind you that we also have other training opportunities available. We can do the one-on-one remote sessions where we can log in and train just your staff one-on-one. We also are doing an HRV seminar with Dr. Gary Bernstein here in Columbus coming up. So if anybody had any questions about that and hasn't got any information from the newsletter, just let us know and we can get you a seat. There's just a few remaining, but if you are interested in traveling out for that, it's a great opportunity, to hear from basically the guy who wrote the book on this. So um, again, please let me know if you guys are interested in that afterwards. Okay, we have a question about where does respiration come into play with an HRV. So respiration is not required, but it does help to validate RSA. The peak frequency of respiration, which is right here, should basically roughly align with the peak frequency and the heart rate power spectrum. If it doesn't, then it's an indication that there might be an additional editing needed in ECG waveform. So HRV will turn the respiration peak frequency red if this is the case. So this basically would turn into like a red value. Okay, we have a question of why did I have the Z0 and DZT mapped on the setup screen. So I'll go back to that to show everyone what we're talking about. Okay, so these were mapped basically. So if this same data set was used in impedance, then if you go to load this again, all your user preferences are going to be there, and they're going to automatically be mapped for you. So that's what happened in this case. Okay, we have another question here, just trying to clarify when the values would basically what would cause the respiration peak frequency to turn red, which we were just talking about. So this right here, what would cause this to turn red? So again, what we're trying to do is the peak frequency of this respiration should roughly align with the heart rate power spectrum. So if these values basically don't line up, then this would cause this to turn red to say that something needs to be looked at within that. Okay, we have about 10 minutes left here. So again, if anybody has any questions at all, please go ahead and send them in. And actually, while we're waiting for some more questions to be sent in, I'm going to go ahead and show you guys the support site knowledge base articles, just to show you kind of how that works. Okay, so I've gone to support.mindwaretech.com, and we have our knowledge base here. There's a few different things we can do through here. Let's just go right straight into the knowledge base articles, and then we'll back up to this screen. This is basically where you'll live for all your questions. You'll see a search bar here similar to Google. So if you had any sort of question, let's say like respiration bands. Okay, so all I have to type in is resp, and then it's going to pop up with all of the articles that we have that have anything to do with respiration. And so the first one I can see here is already how to change the bands. So this is exactly the one that I was referencing earlier, right here when I was saying that if you needed to change any of these bands, we have a support site article. This is that article. And so it's basically showing you how to go through everything and change these. And then it's also showing you deciding on what bands to use depending on the age. And then we have a little Steve Porges recommendation here on what you should use, and then the references below there. And then also, please give us a little heads up on if it was helpful or not. I know that sometimes people kind of gloss over those because they don't think that it will actually help, but we are monitoring these pretty closely. So if you feel like there's anything that could be added to it or something that you're still a little had your head scratching about, then please just go ahead and say, whether it was, what could be improved upon it, and we'll work on that. And we also have the feedback right here, where you can just really, really quickly put in what you thought about the article. So that's basically kind of the down and dirty on how that works. If we come back here, if you did have any sort of issues, if you came through here and you felt that that none of these knowledge-based articles really answered all your questions, you could create a support case right from here, put in your information, and this will get sent to basically our support portal, and then from there it'll be sent out to like the next available person. So this is usually the fastest way to kind of get your questions answered rather than just emailing somebody. So that's how you can do that. Finally, this is software updates. This will take you to the page where you can you'll log in and then you can download all of the necessary software. If you guys don't have a login, it's not that you have to have one for each, like one lab doesn't have to have a login. You can have multiple users of the same one. So feel free if you need to go ahead and register for your own account from there. Finally, here's a blog post. We only have one at this time, but basically these will kind of show just some sort of questions about what you want to do scientifically, whether it's the right choice, and explaining them. So keep looking at the blog post so you can see if there's anything in there of your interest. And then just to show you some more in here, of the HRV ones. Okay, we have another request to do just a quick review of the edited data file versus MWI, and then the snap peak and midbeat peak function buttons. So let's go back into that. Okay, so let's see here. So the MWI files, and I'm going to load a different file. Okay, so the MWI file is what you're going to load into HRV every time. That's what when it pulls up, that's what you're always going to load. And basically what that MWI file is doing is it's indexing to your MWX file. Your MWX file is the raw data, and so that's what we never touch. So here's your MWX file, and then here's your MWI file. These two are just temporary files because I have the program open, so those will disappear as soon as we close it out. So the MWI is what you would always load in the beginning. The EDH file for heart rate is basically just those edited data. So those are what you would load from here. I think I had it in here. So this right here is what the EDH is, basically only the edits that you've had for that one. So those are the difference between the two. So the EDH, if you were to try to load that in the beginning, then it wouldn't work. So you still need to load your MWI, and then you load the EDH later, which is your edited data. And then the snap to peak and midbeat peak functions. Okay, so this is a different data set, but we're going to use this. Okay. We'll just go in here. Okay, so question is, we want to go over basically again the snap to peak and midbeat peak functions. So let's zoom in a little bit here. So snap to peak. So what that's going to do is, if I wanted to insert, let's say here, let's say I wanted to insert an R peak right here, but I didn't, and I had snap to peak off. So what it's going to do is I'm going to kind of guess where it is. Well, if you noticed, I wasn't very accurate with that, and so it's a little off. The snap peak function is basically going to look within this circle here. It's going to look within that, and it's going to find the highest point of the actual ECG, and it's going to place that where it should be. So it's actually something you want to probably leave on. So within this circle, snap to peak's on. It's going to find the highest point and then put it exactly there. But you know, again, if you were having if you had a noisy file and you were just having issues with that, you can also turn that off and then just zoom way in to where you think it should be and then place it there. And then the midbeat peak function buttons. I think we actually had a pretty good example of this one in the other file, so let's load that back up. Okay, so let's do this again, because I haven't loaded my edited data file. Okay, so right here, this is a good point for that midbeat peak function. And sometimes why you'll want to leave that off is just because if there's a lot of noise and it puts it at the wrong spot. So again, I have my X cursors aligned here, and I hit midbeat. But for whatever reason, this peak's a little higher, so it's trying to pick that one as the midbeat in between, because my midbeat auto peak is on. So this peak is higher than this one, it's finding that. That's wrong. So what we would want to do is just then turn that off, and then we want to find the correct one. And so if we turn that off, what it's going to do is it's not going to look for the highest point anymore. It's just going to go the amplitude of 0, but it's going to preserve the timing. So amplitude is not concerned, but this is a correct timing for it. And that's helpful in noise like this, because then you can kind of validate which of these bumps is the actual R peak. And so this one's pretty clear, and I come in here, and then we're done just like before. Okay, and let's just go ahead and close it here since it's about 1:30. Again, thank you for showing up for this HRV webinar. If anybody felt like they might find some one-on-one training for their lab beneficial, please let us know and we can schedule that for you. Additionally, I highly recommend the HRV seminar that we're going to be conducting here with Dr. Gary Bernstein in Columbus. So if anybody felt like they could make the trip out or wanted more information about it, I think there was a news article that speak to it that you should have received in your email. But if not, we can also just chat about it one-on-one. So, but thanks again for showing up, and I hope everyone has a great day.